Good afternoon, students. Welcome to one more amazing session from Infinity Lane by Sri Chaitanya. How are you all? This is Suresh, Faculty of Chemistry from Infinity Lane Studio. Great to see. Good Arav, good afternoon. And Anamani, good afternoon. How are you all doing? Fine, good. So today's topic of interest is chemical equilibrium, and welcome to NEET Step Up 2025 sessions from Infinity Learn. Infinity Learn launched NEET Step Up program in the month of May, and we are running seamlessly all sessions, physics, chemistry and biology, right from 12 o'clock to evening 6 o'clock. So we all notify the students to join the sessions on a regular basis and get advantage of this, and like the sessions and share and subscribe to the NEET channel of Infinity Learn. And this Infinity Learn on YouTube platform, we are giving the sessions those students who are regularly attending these sessions and getting advantage of these sessions. My dear students, you take these sessions, and in 2023 and 24 also on YouTube platform, many students secured medical ranks only from this Infinity Learn platform. So what exactly Infinity Learn is doing for the student community? Hi, Arpit Pandey, hello. And favorite, what is that? Hi. Okay, so I want to see the student name actually. Arpit Pandey, good afternoon. And every students, I can find those students who are regularly attending the sessions. Really, I appreciate them, and they are doing the best for the NEET exam preparation, and we are also doing the best for your preparation. What Infinity Learn is doing to the students who are preparing for NEET examination. Just I want to give you a small illustration here. These 4 students on the slide you can see: Ashrita, Himadyuti, Akhil Verma, Satyanarayan. And these students, just check the comparative picture, and Ashrita got 310 marks in 2023 examination dear, and she got 661 marks in 2024 after taking Infinity Learn courses. You see the impact of 351 marks. It is not so simple, but she could able to do. That is the power of Infinity Learn. The Infinity Learn academic programs are designed in such a way that there is a definitely substantial and phenomenal improvement. You can see Akhil Verma got 223 in 331 in 2023 marks, and 658 345 marks बढ़ गया इनको, है ना. And also you can see Himadyuti, she got only 310 like this, and she secured 652 marks, and there is a 342 marks increment. How it is possible? And a फालतू चीज का नहीं, yes, असली चीज का. On YouTube platform is everything is perfect and it is open, and we are just from Infinity Learn by Sri Chaitanya want to give only genuine results. And King Khan King मैं हिंदी में बात कर सकता हूँ. सत्यनारायण 223 में he got only 330 marks बेटा, and in 2024 650 marks, इनका 320 marks बढ़ गया. And I want to say, and these are all how it is possible. It is possible by various programs. So I will come back to this, and when the live session is going on, in this live session I just want to say, in the NEET program, this is my live session. So you click on this is my live session that is going on, and the description box on the live session, you are going to get a link. So you all just click on the link. You can see here, yes. Click on the more, and you will be getting various links over there. In that various links, you will be given yes your program in the NEET. There you can go to the what are the programs that are available. From there you can enroll it. Okay. Now when you enroll it now, you will be given prompted to a payment gateway, and I'll start the lecture. Okay. In the payment gateway, you just see Suresh 50 is your coupon code, where the coupon code gives you flat 20% discount. In that flat 20% discount you are going to get इतना सस्ता में आपका कोर्स मिलेगा and you can make an awesome journey with Infinity Learn in YouTube and also on online platform for your NEET examination preparation. Yes, be patient. Okay, so Arpit Pandey, shall we start? And today I just want to give you the chemical equilibrium, and tomorrow I just want to give you ionic equilibrium, total concept as well as the questions. That is the agenda for today's class. In previous lectures we discussed some part of the chemical equilibrium, and we are going to get into the continuation of this mode of representation of the chemical equilibriums and the factors affecting equilibrium constant. What is equilibrium constant? You can say A plus B gives rise C plus D, and Kc is given as concentration of C and D and concentration of A and B, and this Kc value is a constant. This Kc value is a constant, is always a constant. जब तक टेम्परेचर कांस्टेंट है Kc वैल्यू बदलते नहीं, लेकिन Kc वैल्यू आप बदल सकते हैं द स्टोइकियोमेट्री का हिसाब से एंड द डायरेक्शन ऑफ द रिएक्शन. एंड यू कैन सी इफ द रिएक्शन इज रिवर्स्ड, अगर रिएक्शन रिवर्स करेंगे तो क्या होगा, A plus B become C plus D and C plus D become A plus B. In that case you can see Kc dash is equal to A dot B upon C dot D. So that what is the relation between this Kc and this Kc dash? अगर Kc dash उल्टा करेंगे तो Kc मिलेगा और Kc उल्टा करें तो Kc dash मिलेगा. So Kc is equal to 1 by Kc dash. I just want to talk about the factors affecting the equilibrium constant. ये पहला जो चीज है mode of representation is the first point. Got it? Clear? That's good. And for example you can see nitrogen plus 3 hydrogen gives rise ammonia. मान लो ये Kc5 होगा, अगर रिएक्शन उल्टा करने तो आपका Kc डैश मिलेगा. सो इट इज गोइंग टू बी 1 by 5. इसका वैल्यू 0.2 का है. अंडरस्टैंड बेटा? राइट. एंड दूसरा बात है कि स्टोइकियोमेट्री ऑफ द रिएक्शन. इन द स्टोइकियोमेट्री ऑफ द रिएक्शन मान लो ये केमिकल रिएक्शन NO2 गिव्स राइज N2 plus O2. Sushrutananda Chatterjee. Hi Sushrut, father of ancient Ayurvedic surgery, Sushruta. Remember? Good name? Yes. Now, when the reaction is given 2 NO2 gives rise N2 plus 2O2 and you divide the equation by 1 by 2, you are going to get N2 NO2 gives rise half O2 of N2 plus O2. Yes, Hema, that's good. So ये रिएक्शन का हिसाब से ये कैसे बनेगा? That is N2O2 square upon NO2 square. And ये रिएक्शन के हिसाब से Kc डैश क्या? It is going to be N2 plus N2 power half dot O2 upon NO2. ये दोनों का क्या रिलेशन है? अगर ये वाला स्क्वायर करना तो so Kc dash square is equal to Kc. I just want to say Kc dash is equal to root over Kc. So you need to cleverly and smartly should understand the relation between these two. Are you getting or not? Clear? Fine. That's good. So that much pace we need to maintain when you prepare for NEET examination. तैयार है आप लोग? Got it? Clear? Fine. Now one more thing. The temperature. Temperature is the only factor which can directly impact the equilibrium constant or any kind of rate constant. So let us मान लो at temperature T1 में rate constant K1, temperature T2 में rate constant K2. So how these two are related with respect to enthalpy of the reaction or the heat of the reaction at constant volume, then it is given as log K2 by K1 is equal to minus enthalpy of reaction upon 2.303 R of 1 by T2 minus 1 by T1. This is popularly known as want-Hoff reaction, want-Hoff equation. yes, this is one half equation. Got it? So a one half equation के हिसाब से आपका थियरी और डेरिवेटिव टाइप ऑफ क्वेश्चंस मिलेगा नीट एग्जामिनेशन में. न्यूमेरिकल सीधा इसी का फॉर्मूला के हिसाब से नहीं पूछना है, बिकॉज कैलकुलेशन इतना लंबा होता है ना. यस, very good. This is very, very important. So I just want to write it for you in a simple way. Logarithm to the base 10 of equilibrium constant K2 upon equilibrium constant K1 is equal to minus enthalpy of the reaction upon 2.303 R value 8.314 joule Kelvin inverse mole inverse होगा बेटा, and it is going to be T2 minus T1 upon T1 dot T2. So you can simplify this and you can go with kind of any type of applicative oriented questions based on this in NEET examination. Got it madam? आगे बढ़ो. सुश्रुता, हरे कान किंग, वेरी गुड. हेमा, एनी डाउट? अगर डाउट है ना तो पूछना. यूज दिस शॉर्ट बॉक्स लाइक एनीथिंग generously and you can ask any kind of doubt so that we can have this is YouTube platform. On YouTube platform it is not like a radio transmission and rather it is going to be like a live interactive session. Got it? एक minute. राइट, तो आगे बढ़ते हैं. नेक्स्ट, डेल्टा H इज जीरो, नेदर हीट इज एब्जॉर्ब्ड नॉर इवॉल्व्ड. ऐसे ये इक्वेशन इस्तेमाल करके हम कैसे ये एप्लीकेशन करना है. इफ डेल्टा H इज जीरो फॉर सच काइंड ऑफ रिएक्शन देर इज नो heat loss, there is no heat gain, so that log K2 minus log K1 is going to be 0 and तभी log K1 is equal to K2, K1 is equal to K2 का मतलब क्या, अगर टेम्परेचर बढ़ते जाओ कम होना है, so rate of the reaction do not change and equilibrium constant also do not change. Thus the equilibrium constant remain the same at all temperature if the temperature T2 is higher than T1. So 1 by T2 minus T1 is less than 0, then K2 minus K1 is going to be, so it is going to be negative and it is going to be negative delta H upon 2.303 R. So if that is the case, when delta H is going to be positive, then it is going to be endothermic process. The reaction in which the heat is entering into the reaction system is called as endothermic process, where K2 log K2 minus log K1 is greater than 0, then log K2 is greater than K1, then or log K2 is greater than K1, and the value of equilibrium constant is higher at higher temperature. I mean to say, अगर temperature बढ़ते जाओ and equilibrium constant बढ़ते जाएगा, and that is for endothermic reaction. And when delta H is negative, that is called exothermic reaction. Let's talk about delta H is negative. It is going to be exothermic reaction. For exothermic reaction, as temperature value is increased, rate constant is going to be decreased and equilibrium constant is going to be decreased. Log K2 minus K1 is less than 0 and log K2 less than log K1, K2 is less than K1. And the value of equilibrium constant is lower at a higher temperature in the case of exothermic reaction. So Kc is directly proportional to 1 by T. मैं ये बोलना चाहता हूँ. This is the one. Got it, my dear children? So Sushritananda, fine. And this is the application of 1/2 equation. I just want to say, in a simplified version, delta H is 0. Temperature has no effect. If delta H is going to be positive, equilibrium constant is directly proportional to temperature. If delta H is going to be negative, equilibrium constant is inversely proportional to temperature. This is a simple way. In my classes, I just want to explain the entire subject as well as simple techniques. I knowledge king, कैसे है, क्या हालचाल है, okay. So make a note of it. Case 1, case 2, case 3. The total ionic equilibrium I am going to revise tomorrow. Ready? In all cases, total formula भी. And so the value of equilibrium constant is independent of the what are the factors. So the factors are going to be the multiple choice questions in the NEET examination. मान लो ये NEET examination में physical chemistry means सिर्फ numerical ही आना है. So numerical का वजह से आपका theory question भी और logical questions भी आता है. Okay बेटा, हेमा कैसे? Now let us say they are independent on initial concentration of the reactants. Yeah, ठीक है. And also in the presence of a catalyst. Catalyst has no influence on the state of equilibrium. Catalyst has no influence on equilibrium constant. Rather, catalyst is used to reach the equilibrium sooner. Okay, catalyst has no influence at all. And the direction from which the equilibrium has been attained. And take a empty vessel, put hydrogen and iodine, HI banega. So in that you can see, in this empty vessel you introduce H2 and I2, you are going to get H2 plus I2 gives rise to HI. In this equilibrium is achieved. And the state of equilibrium you can also get in the experiment too by introducing into the empty vessel HI introduce करो, तभी आपका HI is dissociated to gives rise H2 plus I2, है ना. So the equilibrium is attained in this way or on that way, and the equilibrium constant is going to be the same, and also the presence of inert materials. So the presence of inert materials can change the direction of the equilibrium maybe, but equilibrium constant का ही नहीं, है ना. Hi knowledge king, fine. And you can see which of the following ये multiple choice question का है NEET examination में. That's good, lovely students. And also question, let's do some questions. So एक question कौन कर सकते हैं? For a reaction E plus F gives rise to G plus H. One starts with 6 mole of E and 7 mole of F in 1 liter vessel, 1.0 liter vessel. When the equilibrium is completely attained, 4.5 mole of G is formed. Calculate the value of equilibrium constant for the reaction. आप पेन एंड पेपर पकड़ के ये क्वेश्चन आप खुद करके एक आंसर, लेट इट बी रॉन्ग, एक बार देने तो मैं खुश हो जाता हूँ एंड आपका अच्छा होगा. सो प्रैक्टिस करने का तरीका सीखो, सीखना है. आई विल टेल यू हाउ टू डू दिस. E plus F gives rise G plus H. So पहले ये 6.0 मोल ले ला and it is going to be 7.0, and in 1.0 liter vessel when the equilibrium is attained 4.5 mole of G is formed. So that 4.5 G is formed. When it is 4.5 is G is formed and उतना ही H form होना चाहिए. So 4.5 7 से subtract करो and 4.76 से subtract करो, so that is the equilibrium constant. and उसी से equilibrium constant आप निकाल सकते हैं. कैसे करना है? so equilibrium constant आपका आना है G concentration and H concentration and E concentration and F concentration. ठीक है. so that you directly put the values. फटाफट करके बताओ, फटाफट करके बताओ. मैं हिंट दे दिया ना, एक्सप्लेनेशन दे दिया. कौन करना है? मैं करना है. Children, and it is explained like this. So 4.5 upon 1, 4.5 upon 1 वही है ना. upon 1.5 upon 1 and 2.5. So 1.5 कैसा निकला? 7, 6 minus 4.5. 7 minus 4.5, 2.5. You are going to get equilibrium constant 5.4. That is equilibrium constant 5.4, right? So I just want to say in other ways you can say 4.5, 4.5, 6.5, 6 minus 4.5, 6 minus 4.5 and 7 minus 4.5. So you are going to get a 5.4 is the Kc value at the same temperature. That's good. अरे बेटा knowledge king आपका नाम मैं भूल गया, sorry. So you are one of my regular student, okay? Yeah. So knowledge king मेरा क्लास में knowledge बढ़ते जा रहे हैं. ओके, नाउ और एक क्वेश्चन आपके सामने तैयार हो. या पंकज भूल गया सॉरी पंकज. राइट, द इक्विलिब्रियम कांस्टेंट Kc फॉर द रिएक्शन ऑफ H2 विथ I2 इज 57.0. दिस इज आपका Kc वैल्यू. सो H2 प्लस I2 गिव्स रेसिच Kc वैल्यू 57 दे दिया. Hi, Nakabash. Okay, funny names. And if 1 mole of hydrogen is allowed to react with 1 mole of iodine in 10 liter of vessel at 700 Kelvin, what are the concentrations of H2 and I2 at equilibrium? So what is the composition of equilibrium mixture? So this question has two parts. This is your question number 1. And this is your question number 2, and this is kind of क्या बोलना चाहता हूं, रिट्रैक्ट करो, मैसेज रिट्रैक्ट करो, मैसेज रिट्रैक्ट करो. Right? So I want decent charting in the classroom, my dear students. So you can put fiery emojis and thumbs ups and positive pricings, and you can't be rude with our faculties, right? Take back your statement. I expect all the students to be good in the class. Right. So in these two questions, yes, in these two questions, one question can be a part of one MCQ, another question can be from another question, so that multiple choice questions can be given from any kind of data oriented. So this is the data given from the experiment. From that experiment you can do the questions, right beta? So, and here it is, you can see the first question. So when you want to go for this, any type of that data oriented questions, let us say first you have to write the balanced equation. You follow the sequence of the methods I want to give you. You follow this sequence and you can do any kind of numerical, right? In this, write the balanced equation. Under the balanced equation, make a table that lists out each substances involved in the reaction, like this you can see. In this, H2 plus I2 gives rise to HI. So this is the balanced equation. इसका Kc क्या लग रहा है? And 1 mole of each substance, you can see 1 mole of hydrogen initially reacted with 1 mole of iodine, 1 mole of iodine, and in 10 liter vessel. So what are the concentrations of H2 and I2 and HI at equilibrium? So when the time is equal to 0, when the time becomes equilibrium, so let us say X amount is consumed, so 1 minus X बचेगा and 1 minus X बचेगा, ये 2X form होगा, पहला 0 था, and it is going to be Kc value is going to be HI square upon H2 and I2, right, and it is going to be सब इक्विलिब्रियम में सब 10 मोल ऑफ दी वेसल में है, 10 लीटर ऑफ दी वेसल में है, सो दैट इक्विलिब्रियम कॉन्सेंट्रेशंस H2 you can see, that's what I want to say. The initial concentrations likha, the change in the concentrations on going to equilibrium, change in the concentration 1 minus x 1 minus x likha, and also you have seen the equilibrium concentrations. So the equilibrium concentrations ये 1 minus x होगा, ये 1 minus x होगा, ये 2x होगा. That's what this is the methods. Once the class is completed, you should have a appropriate notes, sir, what exactly happened during the class, है ना? So the substitute the equilibrium concentration into the equilibrium equation. Yes, that is equilibrium equation, you can see. Okay, in that equilibrium equation you can say H2 concentration मिलेगा आपका number of moles 1 minus x से 10 लीटर moles per liter ना, number of active mass of I2 फिर भी 1 minus x by 10 and active mass of HI is going to be 2x by 10. 2x है ना ये वाला. Yes, I want to say here Kc value 57 को equate करके 1 minus x by 10, 1 minus 2x by 10, that is going to be 2x by 10 whole square, 1 minus x by 10 and 1 minus x by 10. So that solve for x, solve for x. Look at this. The calculate the equilibrium concentrations from the calculated value of x. Solve for x. Got it? So this is the flow chart everybody maintain. Dear students, in my class under this description box, Telegram channel is also given. In this Telegram channel, you all just join so that सारे के सारे notes आपका PDF form में मिलेगा and you can justify what are the questions you are preparing during examination. The methodology एक slide बना के आपका रख दिया मैं step 1 का, step 2 का, step 3 का and step 4 का. And solve for x, यहाँ पर solve for x by using a quadratic equation. And you can also calculate Kc and Kp, check your results by substituting them into the equilibrium equation. Again, that is a cross checking because marks NEET examination में marks मुफ्त में मिलता है नहीं बेटा, आप मेहनत करना पड़ता है ना? Yes, मेरा बच्चों लोग बहुत अच्छा है, बहुत मेहनत करता है ना? Yes, and अच्छा तरफ अभ्यास करो, अच्छा तरफ रिजल्ट मिलेगा as a byproduct. Okay, right, now let us use the same here. So initial concentration 1, 0.1 and 0.1, minus x, 0.1 minus x, 0.1 minus x, 2x. So it is 0.1 ले लिया और 1 ले लिया, याद नहीं, okay, कोई problem नहीं. So on solving you are going to get x, the x value is going to be 0.136. Yes, जैक स्पैरो फिर भी आए तो वेरी गुड, कल नहीं मिले परसों आए थे. या ट्राई टू बी रेगुलर एंड डू वर्क नाइसली एंड चार्ट इन द क्लास नाइसली. ओके, एंड आलतू फालतू चार्टिंग नहीं देना. अच्छा स्टूडेंट अच्छा तरफ काम करेगा, है ना? नेक्स्ट, सो कैलकुलेट. So for 0.5 mole of hydrogen and 0.5 mole of iodine react with a 200 liters flask at 448. Yes, knowledge king, you are such an awesome student, given a beautiful answer. Congratulations, good. Okay, right. And you have the equilibrium constant is 50. So I am asking you to calculate what is a Kp and calculate the mole of iodine that are available at equilibrium. कौन कर सकते हैं? So Jacques Sparrow will give the correct answer. So there is a competition between Pankaj and Jack Sparrow. Come on, who will give the first answer? Yes. Okay, come on. Very good involvement from the students during the class. Really on the YouTube platform, because of you guys I am really enjoying. Okay, fine. I'll wait. I'll give 2 minutes. Meanwhile, if any doubts are there, you just ask Jack Sparrow, Taj. Waiting for your answer. मैं करना है. अरे NEET examination में you just see one question is given, you have to finish the answer within 1 minute. है ना? Yes, within 1 minute. Because questions ऐसे करना. Okay, let us start. Now when you talk about H2, I2 gives rise HI. H2 0.5 था and I2 भी 0.5 था, and Jack Sparrow you can see if X amount is consumed and is going to 2x at equilibrium. So for this delta n is equal to 0. So what is delta n? Delta n is equal to sum of the number of moles of gaseous products minus sum of the number of moles of gaseous reactant. So delta n is equal to, here 2 moles are there and 1 mole and 1 mole, 1 plus 1 is equal to 0. So delta n is equal to 0. We know that delta Kp is equal to Kc. We know that, yes, 0.11, very good. Kp is equal to Kc RT to the power delta n. So if this is the case, agar delta n is equal to 0, Kp is equal to Kc. Okay, delta n 0 hai na. And Kc is equal to 4x square upon 0.5 minus x whole square. That is 2x minus 0.5 minus x is root 50, and on solving I2 concentration comes to be x value is 0.39 and it is 0.5 से subtract करो आपको 0.11 मिलेगा, and Pankaj has given absolutely correct answer and appreciated. Jack Sparrow there? That's good. Fine. Next one more, extent of the reaction and equilibrium constant. That is what you call it as we need the equilibrium constant Kc. हमको क्या कहना चाहता, जिस रिएक्शन में Kc वैल्यू ज्यादा हो ये इक्विलिब्रियम हमेशा आगे बढ़ने का कोशिश करता है, एंड वाइस वर्सा. Yes, that's good. I appreciate it. Thank God. Good, nice. Pankaj, very good. Now, जिस रिएक्शन का रेंज क्या होता है, Kc वैल्यू का जो रेंज है, अगर Kc वैल्यू 10 पावर माइनस 3 से कम होगा, रिएक्शन हमेशा पीछे आने का, बैकवर्ड आने का कोशिश करता. Whenever the reaction has a Kc वैल्यू 10 क्यूब से ज़्यादा हो, रिएक्शन हमेशा आगे बढ़ने का कोशिश करता, इक्विलिब्रियम हमेशा आगे बढ़ता. सो अगर हमेशा इक्विलिब्रियम आगे बढ़ता है तो ये इक्विलिब्रियम मिक्सचर में प्रोडक्ट डोमिनेट करता, एंड व्हेन द रिएक्शन बैकवर्ड से ज़्यादा फेवर करने तो ये रिएक्शन मिक्सचर में आपका रिएक्टेंट डोमिनेट करता. When the equation equilibrium constant 10 पावर माइनस 3 से 10 पावर 3 तक 10 क्यूब बीच में रहने तो इक्वेशन आगे बढ़ने का कोशिश करता है एंड बैकवर्ड आने की भी कोशिश करता है. तभी इसी वक्त में ये इक्विलिब्रियम में एप्रिशिएबल अमाउंट ऑफ रिएक्टेंट एंड प्रोडक्ट भी रहना है. अंडरस्टैंड माय डियर चिल्ड्रन? That's very, very important, judging the extent of the reaction by considering the Kc value. Higher the value of Kc, equilibrium reaction is forward dominant, and the lower the value of Kc, reaction is backward dominant. and moderate value of Kc between 10 power minus 3 से 10 cube तक है, equilibrium neither direction dominates, so that both are proceeded. Got it, my dear children? Any doubts? Come on. And from here we need to go into the reaction extent and reaction quotient. That's good. Now let's talk about the reaction quotient. No doubt, very good. बहुत अच्छा important चीज़ है वाला reaction quotient के QC. ये आपका KC का जैसे है. Okay, so misprinted. Okay, let us say, let us ignore this. Let us talk about let's say A mole of A reacted with B mole of B and reversibly gives a C mole of C and a D mole of D. In this case, QC is written as reaction quotient. It is going to be C to the power C, D to the power D, A to the power A and B to the power B. ये क्या बोलना चाहता हूँ? ये वाला Kc का जैसे ये रिएक्शन का Kc का होगा, Kc इज इक्वल टू सेम होगा C to the power C, D to the power D and A to the power A and B to the power B. So in this case ये दोनों क्या है? Kc and Qc are both are same, लेकिन ये पकड़ने का वक्त अलग है. Kc सिर्फ इक्विलिब्रियम कंडीशन में लेता and Qc is any condition, any instant during the reaction. This could be before the equilibrium, this could be after the equilibrium. Are you getting or not? So I just want to say, if Kc is equal to Qc तभी a reaction equilibrium condition में होगा, और Qc कम है Kc ज़्यादा है, सो इक्विलिब्रियम हमेशा फॉरवर्ड के फेवर करना है. एंड यू कैन सी अगर Qc Kc से बड़ा हो रिएक्शन पीछे आने का कोशिश करता है. बस इतना है इक्विलिब्रियम कॉन्सेंट्रेशन, इक्विलिब्रियम कॉन्सेप्ट का एप्लीकेशन है. अंडरस्टैंड? यस, दैट्स वेरी गुड. एंड ऑल्सो यू कैन सी ए ग्राफिकल पिक्टोरियल रिप्रेजेंटेशन है बेटा. ये अच्छा तरफ इमेजिनेशन आपको दे सकता हूँ. अगर Qc वैल्यू Kc से कम है, रिएक्शन गिव्स राइज अ प्रोडक्ट, ओके, एंड मूवमेंट टुवर्ड्स द इक्विलिब्रियम, क्योंकि Kc वैल्यू बड़ा है रिएक्शन आगे बढ़ता. ओके, अगर Qc Kc वैल्यू दोनों बराबर लग रहे हैं, वेरी गुड, एंड रिएक्टेंट एंड द प्रोडक्ट्स आर इक्विलिब्रियम. ओके, नाउ अगर Qc वैल्यू बढ़ा है तो इक्विलिब्रियम पीछे आने का कोशिश करता है, सो दैट प्रोडक्ट गिव्स टू द रिएक्टेंट. सो दिस इज द पिक्टोरियल रिप्रेजेंटेशन दैट गिव्स ये Qc एंड Kc वैल्यू. क्या बोलना चाहता हूं आपको? आर यू गेटिंग और नॉट? क्लियर? फाइन, दैट्स गुड. And this is actually application of Le Chatelier principle in case of effect of concentration, right? But of course Kc value कोई बदलना नहीं, जब तक टेम्परेचर कांस्टेंट है Kc वैल्यू हमेशा कांस्टेंट है. ठीक है, दैट्स गुड. नाउ लेट अस टॉक अबाउट एनी मिक्सचर ऑफ और एक क्वेश्चन. पंकज, कम ऑन. पंकज, आर यू देयर? And a mixture of 4.2 moles of nitrogen, 2.0 moles of hydrogen and 10 moles of ammonia is introduced in 10-liter vessel and at 500 Kelvin. At this temperature, equilibrium constant Kc is 1.7 into 10 square. Okay, and for the reaction N2 plus 3H2 gives rise to NH3. Is the reaction mixture is at equilibrium? चेक करना पड़ता है. If not, what is the direction of equilibrium? अब yes, थोड़ा सा करके बताओ पंकज, थोड़ा सा करके बताओ. Now let me introduce you. N2 concentration 4.2 upon 10, because 10 liter vessel it is going to be 0.42. H2 concentration 2.0 upon 10 is going to be 0.2. Ammonia, अर्पित पांडे कहाँ गए तू? नेटवर्क इश्यू चल रही है क्या? Okay, I'll wait. You just give me. So NH3 10 liters 10 moles upon 10 is going to be 0.1, 1.0 beta. ये वाला 1.0. 1.0. And for this concentration, the reaction quotient is given as, and so you can do it. N2 plus 3H2 gives rise to NH3. Kc value, QC value is given as NH3 square N2 and H2 cube. In this case, you just see NH3 concentration कितना दिया? It is 0.1 square. And N2 कितना दिया? 0.42. It is going to be 0.2 square. है ना? So network issue to your mobile. Okay, try to attend the class. Arpit Pandey, try to attend the class with a good network areas, preferably by using a tab or preferably by using a laptop. Okay. QC कितने निकलेगा? QC आता है आपका 0.1 square upon 0.42 into 0.2 cube is going to be 2.9. अरे KC value इतना है and QC value इतना है, so that we can say Kc is given as 1.7 into 10 square, and since the Qc is not equal to Kc, the reaction is not at equilibrium, and as the Kc is greater than Qc, the reaction will proceed from left to right, आगे बढ़ने का कोशिश पड़ता है. Got it? कीर्तना मुरुगेसन, ये IQ result will release. Array, that is in different channel here. We are discussing chemistry here, Kirtanam. 2.97. Yes, your answer is correct. Your answer is correct, Arpit. Okay, तैयार है और क्वेश्चन करने का? Not at equilibrium. Yes, of course, it is not at equilibrium. Yes, you said is correct. Arpit Pandey, correct. Aril, आंसर से लग रहे हैं. That's good. और एक क्वेश्चन तैयार है. Now, so calculation of degree of dissociation from vapor pressure density measurement and a चीज बहुत important है for especially for NEET examinations का. When the vapor is when the gas substance is dissociated and it is giving rise to this vapor, and there is an equilibrium between undissociated and dissociated substance. So the total vapor state has a density. Because of this dissociation, the vapor density is changing. Based on this vapor density, degree of dissociation can be calculated. Degree of dissociation is represented as alpha, number of moles dissociated. Your answer is perfect, beta. Your answer is perfect. Pankaj is named as knowledge king. You are not a knowledge king, you are a knowledge emperor. Okay, lage raho. That's good. And alpha is equal to number of moles dissociated upon number of moles taken. So if 100% dissociated, alpha is equal to 1 or 100%. If for less dissociation, alpha is less than 1. Right, beta? Got it? So it is the degree of dissociation of a substance at a particular temperature is defined as the fraction of the number of moles dissociated to that of total number of moles that are being taken. Got it? And what is the relation between the degree of dissociation alpha and the vapor density? And you can see when PCl5 is dissociated to gives rise PCl3 and Cl2, and initially 1 mole, मान लो 1 mole ले लिया मैं, it is 0 and 0, and number of moles after, if it is alpha is the degree of dissociation, 1 minus alpha and alpha, and the total number of moles is equal to 1 minus alpha, okay, plus alpha and plus alpha. So that we are going to strike this is going to be 1 plus alpha. Yes, you wanted to many questions to practice. Okay, definitely. Tomorrow we will be practicing about ionic equilibrium, where I start with basic questions and take you to the advanced level of NEET examination questions. And पहले आपको टोटल आयनिक इक्विलिब्रियम का सारा का सारा फॉर्मूला एक बार आपको रिवाइज करके करना है. आज के लिए आपको मिलेगा क्वेश्चंस, लेकिन क्वेश्चन नंबर थोड़ा कम है ना बेटा? पंकज, इज दैट फाइन? आज के लिए, सिर्फ आज के लिए, ठीक है बेटा? दैट्स गुड. नाउ let's the volume occupied by the vapor per mole is V liters, and the initial vapor density is D, and that is theoretical, and the vapor density after dissociation is small d. Got it? Pankaj, convinced? And the relation between alpha and D, it is simply, it is given as alpha is equal to D minus D, capital D minus small d, and upon n minus 1 into d. You can also say here, you can also say alpha is equal to theoretical molecular mass and observed molecular mass upon n minus 1 into observed molecular mass. N stands here number of moles that are formed after dissociation, and these formulas you please make a cheat sheet so that you can get examination questions from this formula only. Is that fine? Great. Okay, nice gathering in the class. So hundreds of viewers are getting advantage of this NEET YouTube channel classes from Infinity Learn, and I am Suresh, faculty of chemistry, and many fan follow-ups are there. It gives a goosebumps when I become a teacher with Infinity Learn. That's good, very nice. And here vapor density of the equilibrium mixture NO2 and N2O4 is found to be 42 for the reaction. N2O4 gives rise NO2, and abnormal molecular mass इसका क्या होगा, and the degree of dissociation क्या होगा, and the percentage of NO2 in the mixture कितना होगा, and one shot three birds. अर्पित पांडे, आप करना है, मैं करूं? पंकज, that's good, that's good. Okay, I'll wait. To do this question, simple. For the reaction, N2O4 gives rise to NO2. Observed value of vapor density is 42, and abnormal molecular weight is 42 into 2. Okay, and here D is equal to 2. And I just want to say the theoretical molecular weight is 92, because N2O4, 2D is equal to 92, D is equal to 92 by 2, it's 46. Hi Shivans, where did you go? in your absence, her classes are going to be so monotonic. When you are there in the class, class में आग लगते रहते हैं. कलकत्ता केस में नहीं देखा, ओके, लेकिन न्यूज़पेपर में पढ़ा, बहुत बुरा चीज़ है. ओके, लेट अस नॉट डिस्कस अबाउट बैड थिंग्स. Somewhere it is happened, something happened. Here it is YouTube platform by Infinity Learn. We discuss about preparing NEET examination, and in this particular session only chemistry. ठीक है, that is going to be 0.095. Okay, so yes, that's good. And alpha is equal to d minus d by d, that is 46 minus 42 upon 42 is equal to 0.095. That is alpha. So if that is the case, you can say 9.5 is the degree of dissociation, and it is going to be N2O4, NO2. क्या आपका एम चेंज हो गया? आपको बहुत डर लगता है हमेशा. ओके, 1 0 t is equal to 0 at equilibrium, 1 minus alpha is and 2 alpha, and it is going to be alpha is given as a 1 minus alpha and 1 minus 0.19 and 2 alpha is equal to 0.19, and it is going to be 20%. आपको 20% कैसे? अर्पित पांडे, नहीं. And total moles at equilibrium 1 plus alpha 1 plus 0.095. If that is the case, no, Arpit has given on solving 17.35. And my dear students, and this is the typical NEET question. If you do this question, you will be having an idea about how you can solve questions from NCERT and NEET examination. Yes, 17.3. Is that fine? It is 17.3. Right, beta? So, okay. Be a doctor and be service oriented, and you can do the best from your bottom of your heart. And Shivansh, you definitely will be enjoying your life. There are two persons genuinely, one is doctor and a teacher, always enjoys in every moment in his life, because these two professions are service oriented professions. I don't say other professions they don't enjoy, they enjoy, but when it comes to the service, doctor and teacher definitely enjoys. Okay, बुरा मत सोचना. ठीक है बेटा, come on. Yes, your answer is Pankaj, your answer is perfect. Clear? Now, और एक है, calculate the percentage of dissociation of H2S if 0.1 mole of H2S is kept in 0.4 liter vessel at 900 degree Kelvin, and the value of the reaction 2H2S gives rise to H2 plus S2 is 1.01 into 10 power 4, 1.0 into 10 power 4. Okay, आप कर सकते हैं, आप कर सकते हैं, मैं करूं. आज नबी, जय श्री कृष्ण, come on. Yes. Good. You want me to do? Shall I have to? Okay, I'll wait for you. Please do it. आप नए हो, मेरे पता है. So those students who are already there in the session, okay, I know their name, I can understand their performance. You are new to the class. आपका नाम क्या? Ajnabi's name is given, and you are from, and what is your name? Yes. You know my name, and you are in a NEET preparation platform on YouTube channel by Infinity Learn by Sri Chaitanya. Thank you. And my name is Suresh, and what about you? Yeah, yeah. Abhishek, where did you go? Okay. You are coming at the end of the sessions every day. Abhishek, college is started. Okay, come on. Pankaj, I am expecting an answer from you. So, I think your college timing is not permitting 1 minute. Just a minute. Okay, Okay, I'll wait for you, and definitely I am expecting an answer. Perfect answer from you. So, in this case you can say moles of H2S, initially it is 0.1. I can understand, and mole solve कर रहा हूँ को okay copy कर okay 1 minute and college के लिए time नहीं हो रहा है. Whenever those students who are regularly attending, first of all I appreciate them, and those students not able to attend on the regular basis due to their colleges and all, and you just watch the recordings that are available, and you can just give any doubt in the form of comment, and so that we can interact in the comment box itself, right? K Jayadanta, namaste. Namaste. Okay. Okay, solve करो copy पर. I am waiting for you only, Pankaj. आप कितने देर लगेगा आपका आंसर देने के लिए? आंसर देने के लिए. So I just count everything. You got 0.02. 0.02. कमाल किया, appreciated, lovely answer. Okay, dear students, here the initial moles of H2S is 0.1. क्वेश्चन में दे चुका, and it's 0 and 0, and let us say 0.1 से 0.1x रिएक्ट करने के बाद 0.1x फॉर्म होना है, एंड ये भी 0.1x बाई 2 होना है कि अगर 2 होगा तो उसे 1 है ना, ये 1 होगा तो ये 1 by 2 होगा, right? That's good. So at equilibrium Kc is given as H2 square S2 and H2S, and sulfur is given in the gas state. Okay, S2 is existing in gas state, mind it is paramagnetic, ऑक्सीजन का जैसे. NCERT P block में दे दिया. Okay, yes, I teach science, this is science only, Jaitan, namaste. Okay, now we can see 0.1 x by v whole square upon 0.01 by v 2v upon 0.01 minus 0.01 x upon v whole square. Now you can see in this way it is equal to 10 to the power of 4, क्योंकि ये वाला 1.0 into 10 to the power दे चुका. So you can solve for x. On solving x you are going to get 0.02. Got it beta? Clear? Okay, and Abhishek, any doubt? Okay, now let us go ahead. Or ek Le Chatelier principle. Le Chatelier principle says whenever an equilibrium is disturbed, the equilibrium is going to respond in such a way that it will regain the equilibrium. Okay, so how to change the equilibrium system? And you can disturb the equilibrium, yes, by changing the concentration. If concentration is changed, it is going to change the equilibrium direction, and so that to maintain its equilibrium constant, it is going to retract the change. I want to say change in pressure. When the pressure of the system is increased, number of moles per unit volume decreases, so that the equilibrium is going to shift in such a way that it will try to increase the number of moles. Like I just want to say how to just take if the chemical reaction at equilibrium delta N is 0, pressure has no effect. If delta N is greater than 0, if delta N is greater than 0, as pressure is increased, equilibrium shift more in the backward direction. If the delta N is going to be greater than 0, what happened? Agar pressure increased, equilibrium try to shift more in the back forward direction. Simple, it is very simple. Got it? Now और एक चीज है, change in temperature, change in temperature, change in temperature, delta H exothermic है, endothermic है. There are two things, exo temperature increased, you are going to shift the equilibrium backward. Endo, if the temperature is increased, you are going to shift the equilibrium more into the forward direction. हाँ, equilibrium थोड़ा doubt है और एक बार ये session revision एक बार देखना है बेटा. Okay, now I just want to say very important things, very important thing. Introduction of the inert gas, that is a trick I just want to give you. Introduction of inert gas into the equilibrium mixture. In the introduction of inert gas, you can introduce in two ways. When the volume is constant, when the pressure is constant, delta P is equal to 0. When the volume is constant, introduction of inert gas has no effect. Whereas when you introduce inert gas into constant pressure, there are three things you can say. अगर डेल्टा एन मान लो ये 0 होगा, डेल्टा एन ग्रेटर देन 0 होगा, डेल्टा एन लेस देन 0 होगा. So simple trick, I just want to close the session. ये ट्रिक देके आपका use opposite effect of pressure. That's very simple, right? So if delta n is equal to 0, of course no effect. Delta n is greater than 0, reaction आगे बढ़ना है. If delta n is less than 0, reaction favors in the backward direction. So that is such a simple technique. So many students get a lot of confusion in introduction of inert gases for the equilibrium. So it is simply theoretical and logical. You can also do the best out of this concept that I explained today. And today we had a great swell that we started from equilibrium constant and its factors and how to calculate equilibrium constant, equilibrium concentrations, Kc, extent of reaction, QC and Le Chatelier principle and applications, and so many numericals we did in today's class. My students, I just want to tell you, tomorrow we are going to explain some formulas for the ionic equilibrium. At the same time, we will be doing some questions from the ionic equilibrium. So get ready for tomorrow's class, and today please like, share and subscribe these sessions. Okay, thank you very much. God bless you. Signing off. Suresh Avari from Infinity Lane. Bye bye. Thank you.